Our esteemed speaker this evening has been with Fivetran for 5 years. Please welcome the VP of Engineering, Mel Veliste.
Thank you, Eric, for that fun introduction. I think that's the most fun I've seen at the beginning of any of my presentations. So, today, guess what we're talking about? Oh, that one. Talking about database external replication. Who's excited? All right, there we go. So, well, what do we mean by that? Well, it depends on it depends on why you want to replicate. So there are two kinds of replication: internal and external. So if you're replicating a database for redundancy purposes, such as you want to achieve a backup of your database, or be able to achieve automated failover, or make the database highly readable, so you can have lots of clients reading at the same time from a bunch of read replicas. That's internal replication. Why? Because you'd be replicating from the same kind of database to the same kind of database. For example, you have a MySQL master and a bunch of MySQL replicas, or Postgres master and a bunch of Postgres replicas. But if you're replicating for other purposes, such as data pipelines, with this concept of ETL used for analytics, business intelligence, you want to build some fancy graphs that show your business metrics, you want to do some analysis to improve the efficiency of your business, data science, all those purposes, you can do them in that same kind of database where the data is coming from. But you often wouldn't want to, because guess what? Your source database typically is a transactional database, which means it's very good at querying individual records and inserting individual records very fast at very high rates. Not very good at answering questions like, hey, what is the sum of this column across these billion or trillion rows? And for that, you need a data warehouse, which is optimized for the second kind of queries. And thereby, it's going to be different from your source database. And so you need to replicate the data outside of the source database. And that second kind, indeed, is what Fivetran's business is centered around. So, well, what exactly is Fivetran trying to achieve in this space? I mean, that's a big space, a whole big data science rigmarole, a lot of buzzwords flying around. So what are we doing exactly? Well, Fivetran is a managed data pipeline. So the idea is, if your business runs on all kinds of infrastructure, including in-house databases, such as MySQL or Postgres, MongoDB, or many other kinds of databases, but your business might also use cloud applications, such as Salesforce, and you might have your own custom applications sending webhooks to various places, and you might have some files living in various places, such as S3 or even FTP servers. No matter where your data hides and where you keep it and store it and use it for your business, if you want to analyze it, you're going to want to put it in one place. Like, you're not going to want to access 20 different sources to get one answer across different data sources. So you got to put it in a data warehouse. And Fivetran supports 3 different kinds of data warehouses: BigQuery, which was mentioned, and Snowflake, which was mentioned. I don't think Redshift was mentioned in the trivia, but it is also one of our outputs. And so Fivetran's business is to just make it really, really easy for you guys to connect any of these data sources to one of those data warehouses. So let's get a little bit more specific. The topic of today's presentation, of course, is about database external replication. So we're not going to talk about all of Fivetran. We're going to talk about the particulars of database sources. And so what do we mean? What do we mean? Well, first, before we can talk about what do we mean, there are different kinds of databases, and we have to define some common language. So, who can tell me what these terms mean? You all know this, right? Table action, cold factor and rotor. All right, there's a link here. Whoever has a device capable of internet, please go to this link. Go to this link, and there's another trivia quiz for you. Let's see what everyone thinks these terms mean. I'll give you guys a minute. Who's on a computer? Cell phones work? Come on, guys. Let's do this. Can everybody see the link? I think it's too low, isn't it? I'm going to raise that link higher. Let's put it all the way up here. Permission? Oh no. Well, that's embarrassing. I only tested it myself. I think permission should be easy to manage. It's in preferences, is it? Hey, where do you get permissions for these things? Is it when you send it? Oh, that thing.
That's straight, yeah.
All right, try it now. Rigging? All right, that was embarrassing. All right. Elevator music playing. Ah, very good. Did you answer? You don't have a device. Too bad. Yours doesn't count. All right. Who needs more time? Raise your hand if you need more time and you want to answer. Okay. Two people still answering. All right. We have 9 responses. Oh, look at that. Oh, I can see we've got a no-skill audience here. We've got a MongoDB audience. Collections. Oh. Say again? Yeah. I will show the link again right here. All right, you got it? All right, anybody else need more time? I think we gotta keep this moving. All right, so let's see. Oh, nice, 24 responses. I'm just gonna leave it open and see more coming. maybe you guys will try later. So, these things, of course, are very easily called different things. I was making up these terms just for fun to make the point that when we talk about database replication, there are these certain common concepts that are common between all different kinds of databases, and yet they get called different things. And so indeed MongoDB calls these things collections, which other DBs call tables. Personally, I'm more of a SQL database person, so I'd be in that 25% of table. Interestingly, things that refer to columns pretty evenly split: fields, attributes, properties. It's interesting. I would have thought if most of the people here talk about collections, they're Mongo people, they call them fields, right? This is Mongo official term fields for the things in the document. Yeah, see, this is inconsistent too, because MongoDB would say document. So this is very interesting. You're a conflicted crowd, you guys. All right. Right? That's right. So there we go. In any case, so row, document, or record is all same thing for the purposes of this presentation. So is column, field, attribute, and property. And so are table and collection. And finally, we can move on. Woohoo! So, there we go. Now I've defined them for you. And I highlight table, column, and row because I will use these terms in the rest of the presentations, but they can interchangeably mean these other things. All right, so what exactly do we mean by external replication? We talked about that a little bit earlier. We're going to get into the details now. So we already mentioned that it means your source DB type is not equal to your destination DB type. So that's the external part. Replication part is we're going to create a copy of all the tables, and we're going to maintain that copy, as in like a live copy. So if you have a source where you keep changing things in the destination, those changes will be reflected. And so how do we do that? Well, the idea is for each table we need to copy everything about it, its name, its columns, the columns names and types. Attributes are things like primary keys and foreign keys, and of course all the data in the rows. And then once we've made the initial copy, then all we got to do is see what's changed and keep it up to date. Seems pretty simple, right? Because we talk about it all in these common terms. But so wait, so how do we keep them up to date exactly? Now there are a bunch of possible approaches. Who can tell me what's the most traditional approach to this type of problem? Any takers? No, okay. Daily snapshots. Traditional way is you just copy it again. You dump the CSV or have some other way of getting it all out. You do it every day. And it is surprisingly common, and it is surprisingly wasteful. And it's going to put a lot of load on your source database, so you don't want to be doing that. You could rely on last modified dates. That's a pretty popular approach. If every table that you have has a certain column where a timestamp gets updated every time when a row is inserted or modified, perfect. Then you can use that as a basis to select rows that have changed and just update those. You don't have to waste copying them all. Who can see a problem with that? Yeah, you could get duplication if your last modified date is not automated. If it's like created by your application, say, application makes an error in terms of setting the date. How else would you get duplication? Is that what you meant? You said you can get duplication.
I mean, like, suppose if the cycle time is less than the...
Oh, you're talking about granularity. So maybe you're taking the date part too literally, but this is really timestamp, right? So typically it'd be like millisecond accurate at least. It's true you could get two updates within the same millisecond. You could get a duplicate there. That's totally true. But duplicates are often not a problem as long as you overwrite the same row in the destination, right? I mean, it's not really a duplicate. It's more the case that it's just copying the same row again. Slightly wasteful if it happens rarely. Bigger problem though. There's a bigger problem lurking here. Anybody? Big problem with this.
You missed updates. You missed updates.
No, why would you miss the updates?
If it is updated like twice, just like every 10 or 10 minutes, updated twice there.
Well, every time you update, the last modified date should be updated. It needs a timestamp, so it'll be a higher increment. And so you have your replication will have a cursor that says up to what timestamp you replicated. So why would you miss anything?
updates update. I'm assuming that that's like
Yeah, so like if you run an update command on ResourceDB, that doesn't update the timestamp. Right, so the timestamp can become the point of failure there. In some databases, they can be automated so that any update statement will update the timestamp, but not always. Indeed, an even bigger problem is you can't detect deleted rows. How do you detect that with the last modified timestamp on the row if the row is gone? You go finding the date on the gone row. How do you find the gone rows? Well, one way to do that is to add another column. You add a Boolean column, a flag, that says that this row has been deleted. Now, don't actually delete it. But that requires modifying your business logic so that whatever client is writing to the database is going to populate that flag and do it correctly. And so anytime you have to modify business logic, that's a difficult proposition, not exactly a quick setup. What else can we do? Well, we can set triggers, right? You can have a delete trigger, but that requires setup of your database. And anytime you're modifying a production database, we here would like to go and just put a bunch of random triggers in their Postgres master that's serving their website. Any takers? No, didn't think so. So what should we use then? Well, log tailing is of course the modern approach. Does log tailing have any problems? No, it is perfect. Is it? Well, I guess we'll see. Let's talk about it a little bit. So, log tailing means that you have a complete history of changes, a time-ordered sequence of your insert, update, and delete events. And so it should be possible to replicate everything. And every type of database out there has one of these, more or less. For MongoDB, it's called the op log. For Postgres, it's called the write-ahead log, combined with a mechanism called logical slots, which are reading the wall log, which is internal. Logical slots make that readable for external replication. In MySQL, it's called binlog. SQL Server is a kind of an oddity. It has two mechanisms: change data capture and change tracking. Change data capture is more of the real deal in terms of an actual log, but it's not available in every version of SQL Server. So if you want something that works in every version, you have to use this other thing called change tracking, which isn't really a history, but it rather gives you the latest version of every row. If you change twice since your last update, you wouldn't get both changes, depending whether you care about it. Oracle has a built-in log that's some sort of a super secret format. I've never seen a published description of the actual log format. We provide this cool program called LogMiner, which you can invoke over the SQL interface, and it lets you extract the log of changes. And DynamoDB has this thing called DynamoDB Stream. So they all have it. So it's great. Life is great, as we said. Log tailing is perfect, and all the databases have logs. So life is good. Let's move on. What are we forgetting?
Schema changes.
Thank you. An extra shirt for that guy. Do we have more shirts? That's too bad. Very good. Yeah, I think someone was still raising their hand. What else? Something else?
No, I'm the guy who said that.
Okay, yeah, you were the guy that said it. I want to talk to you later. That's very correct. We want to replicate schema changes. So that means, of course, for every table, there's a new table or one gets renamed or dropped. As we talked about earlier, dropping tables. We want to replicate that, right? Same thing for columns. Any new or changed dropped columns. You can change the types of columns. You can change their primary keys. There are constraints, not null or unique, foreign keys. Lots of things can change, and we want to replicate any and all of that, right? That's right. So, to achieve all that, just to recap, to put it all together, like both of these parts already occurred earlier, but put it all together in one slide. This is what we want to see in the logs, all of these things. So data change events as well as the schema change events. And so, now that we have laid that out, like our goal, what we want to see in these logs, i.e. in the ideal world, it's time for a reality check. Who here is willing to bet that most of these features are available in most of those logs that we talked about? Yes.
I bet yes, they are.
Really? You have a no? Yeah, this is a fun. I should put all of these questions and answers on the Google Forms. Then we get to mess with the permissions for every one of them and draw out the presentation. So actually, it's very much a patchwork, the picture. None of them have all these features. And it is disheartening, honestly, for us as Fivetran. We want to make these perfect data pipelines, and here are these databases not letting us do it. But we still do it. And so how do we do it? Well, we focus in on what we can get and what we can't get and find ways around. And so just to talk about some of these things a little bit, the worst offender here is SQL Server. SQL Server, just to give you the colors there, should have had a legend, I guess, but pretty obvious. Green checks are pretty obvious. Red crosses are obvious, I think. The orange ones are like partial, they mean like partial or sort of. So SQL Server sort of gives you inserts, updates, and deletes. It's the only one that has a sort of, all three of them. And it has to do with that thing I mentioned earlier. It has these two mechanisms. One of them gives you all three, but you can't get that mechanism unless you're like some sort of enterprise customer. It's some sort of expensive version that has it. And the normal versions just have this lesser feature that only gives you the latest version of each row. And you don't get any of the schema changes. So that's the worst offender. The best offender, or the least you get the idea, offender is Mongo, with lots of green check marks there. And if this is a largely Mongo crowd, then you guys should be really happy to hear me say this. Mongo has a really good structured log format. It has a perfect record of its inserts and updates and deletes, as well as a good structured representation of some of the changes, like the table changes, certainly. New, renamed, and drop tables are structured events in the Mongo uplog. We still have yellow stars for the other ones, the column changes, because, well, that has to do more with the fact that the data itself is not structured in Mongo, right? So, like, how do you recognize a new column? Well, it's not a red X. You can recognize a new column if that's the only thing that happens. But what if one column gets deleted, another one gets added? Then it looks the same as a rename. So you can't necessarily tell what happened. From Mongo's point of view, it's kind of a moot point, I suppose. But remember, where is this data going? In our case, we're replicated into a SQL data warehouse. So we need to make the decision on the output side, like, is this going to be a rename column or is it going to be a new column? And so it doesn't matter. If you replicate it to a NoSQL destination, then, well, it doesn't. But we don't replicate to NoSQL destinations at this time. So it all matters. Other databases are sort of somewhere in between, and I just want to take a look at some of the details of MySQL and Postgres, which I think are really good examples of how these things actually work. So if you take a look at MySQL bin log, it has multiple formats. In the row format, it just has binary encoding of insert, update, and delete events. So as an example here, if we were talking about people attending this event, we might insert first George, who is our CEO. Well, he's not here. So later you're going to see us delete him. The last line deletes primary key 1, name George. And second one is of course me, and the third one is Eric, who disappeared. Oh, he's in the back now. There you go. You're the third one here. You see that? All right. And then Mel, as it happens, at one point moved from Pennsylvania to California. So we have an update there where we update the state from Pennsylvania to California. So what are the interesting things about this log? Well, I casually, as I explained what this example means, mentioned certain elements that are not actually here. What did I mention? I said primary key ID. Well, does it tell you? It doesn't. It doesn't tell you about primary keys. I also said name and state. Well, we guessed that based on the values, but it doesn't say that anywhere here. MySQL, it's a very bizarre thing in my opinion. They don't put column names in the log. So you got to know what the columns are, and only then you can interpret them. It gives you types and values, no names. So how do you get if something changes about the columns or tables? How do you get that? Well, if you use this other bin log format called mixed format, you can get the PDL events in there as well. Things like this nice create table event. And so this will then tell us the fact that we have a primary key on ID column. We have a column named name and state, and their order. And so that would occur before those insert events in that log. So if we have that, then we're in business, right? Well, not so fast. That same create table event could look like this. See the difference? What's the difference? Well, there's some uppercase, lowercase. That surely doesn't matter. Where I defined the primary key also moved. You see here, primary key is defined as part of the column definition. Earlier it was defined at the end of the table definition. Both are valid formats. SQL is very flexible. So why can it occur in both formats? Well, because MySQL puts this stuff in the log in the original form as the user typed it in the command line or sent via JPC or whatever. So it's kind of it becomes a problem of free-form text parsing. Not so convenient, is it? But surely you would say the create table command has a simple enough syntax. We can handle that. We're smart at Fivetran, right? We can parse a little SQL. But do we want to parse all of SQL? The same table could have been created with this command. How about now? Did you know you can create tables like this by selecting from another table? So now what do? We parse all of this and then go look up the definition of the people table instead? It's getting gnarly. So basically, all of this goes to show that there is not a structured representation of schema changes in the MySQL logs. It is very, very annoying. It's what keeps me up at night. So how do we get this schema information? There must be another way. Well, of course there's another way. We all know what it is. We just create the information schema, right? Information schema has names of tables, names of columns, their types, and their keys. Even other tables that are being referenced. You could join the key column usage table. It's all there. No problem, right? We just go and query it. Well, what's wrong with that? Anybody? What's wrong with it's no longer just log processing, right? Now we have to take a break from log processing and we have to go make these queries. So when do we make these queries? Well, of course, when the table changes. Well, when does the table change? We don't know, right? So basically what you end up doing is you either query periodically or you look for certain cues in the logs. So for example, if a certain table had row events that were always 8 columns and suddenly you have 9, you're not going to know the name of the new column from the log, but it gives you a cue. It says, hey, go look up the new definition. That's perfect, right? So it works out. It's possible to do replication. All right, on to Postgres. What does Postgres give us? Postgres is a lot of fun. I like it. I implemented this log. Actually, no, I implemented the MySQL. I had one of our new engineers implement this one. I studied this topic closely, and it's close to my heart. These Postgres logs are a lot of fun. There's these things called logical slots, right? As I mentioned, that are a mechanism on top of the wall mechanism, the write-ahead log. And these logical slots, they have these things called plugins. And the plugins read the log and then output the data in some particular format. There's a particular plugin that comes with Postgres. It's called test decoding. And it puts out data in this particular form. And it's actually a very good form, very easy to parse, very structured. So it has all the same stuff, right? The same examples. I need to explain the examples again. Make this up through that again. Huh? So, what do you guys see here that wasn't present in MySQL?
Column names.
Yes, thank you. Column names. Oh. Whew, what a relief. Postgres has column names. Great. So then we don't need to do those information schema queries, right? Right? Not so fast. What doesn't it give us? That's right. It doesn't give us primary keys or any of the other attributes. So we still need to query the information schema. Oh well. Well, that works. As we talked about, we can query the information schema. All right, so enough of them examples, and so let's just do some generalization about the shortcomings of the logs, holes, the holy logs. We talked about the top 3 column names are not present in some logs, and reading. Oh, I meant to talk about the second one, primary keyless tables, but didn't. I'm just going to go back to this slide because this is where I meant to talk about it. This delete event right here, it shows primary key ID 1. It's different, by the way, from MySQL log. If you remember, in MySQL log, it gave the full row that was being deleted. Of course, that's unnecessary because you only need the primary key to delete a row, right? Not so fast. What if you have a primary keyless table? Postgres logs will have nothing. It will have a little thing that says no tuples. It's a fun little term, no tuples. And so yeah, another way of saying SOL. Your SOL when that happens. You can't replicate primary keyless tables. Okay, other problems. So the third one we talked about, lack of structured representation with schema changes. And they're also what I like to call forbidden operations. Forbidden, well, not forbidden, but what happens when you truncate a table or drop a table, in a lot of the logs, you don't see those events at all. So then what happens to the rows in your destination warehouse? They get left represented as if they still exist, even though they no longer do. Same thing can happen with cascaded deletes and cascaded updates. That's a lot of fun. It was a recent discovery. We didn't even know about it until recently. then what happens there is, you guys know what cascade deletes are, right? Is it a cascade constraint on a foreign key? So that when you have a parent table and a child table that refers to the parent, you delete the row from the parent, the database automatically drops the child table. At least one of you knew the answer, not a Legan. But like MySQL, for example, the log will have an entry for the parent table delete, but not for the child table. And so now you have to keep track of the cascade constraints just to make the correct replication. And if you want to do history tracking, if you're not just replicating the current state of that database, then you need to have like all the actual events present, not just the latest state. So not all of them have that, SQL Server in particular. And information schema, we talked about reading the information schema, but guess what? For Postgres, for example, you can't get everything you want out of the information schema. You have to go to the PG system tables to get some stuff. And then, do you guys know that primary keys can be null? And they can be duplicate? I didn't know this until, like, I tell you, like, we implemented these database connectors for Fivetran in such good faith, you know, we thought everyone's databases were going to be really well behaved. And of course, sooner or later, what do I see about a failure? Start digging into it, 2 rows with the same primary key. How does that happen? I started digging and yeah, sure enough, it's right there in the Postgres docs. I just didn't read all 100,000 pages of it. You can turn off the constraints, and then you can insert all you want. And then you can turn the constraint back on, and it just says no problem. It'll just continue to exist in this state. Another problem is failover. Failover can create problems with sequentiality of the logs. Like you keep track of the log position that we're replicating, right? And when you fail over, then the log on the new server has a different sequence of position numbers. So you kind of don't know where you're at. There's also problems with, you know, potentially IP addresses changing depending on how things have been set up. So, okay, so these are problems with logs. And additionally, there are other kinds of challenges aside, there are not exactly holes in the logs. Other kinds of challenges that we run into with Postgres in particular. So this the default plugin that I mentioned, test decoding, we kind of have no choice but to implement based on that. I love to make my own plugin and to make sure that it has all the information that it needs to have. I imagine the underlying wall log probably has everything in it, but they don't expose schema changes in that test decoding. So why do we have to make do with it? Well, because most of our customers run on managed Postgres databases. If you're in RDS, you don't have the ability to install the Fivetran decoding plugin. Whatever AWS gives us, we have to make do, and they pretty much just have the standard ones. So yeah, but still, it works based on that standard plugin. It just means you need to do things like go outside the log to read schema information. Also, we found there are 2 ways to read the logical slots in Postgres. You can read it via SQL, just like the log miner thing I mentioned in Oracle, or you can access it via this thing called a streaming interface. If you do the former, your database will crash. How would you like to do that on your Postgres master that's serving your website? Didn't think so. So the thing to do is to use the streaming interface. It doesn't always crash. It's only if you have particularly active logs. Another problem is log retention. And log retention has 2 kinds of problems. So the First problem is with retaining for too long, and the other one is retaining too short. So in Postgres, boggles my mind that if you don't read from the logical slot, if you don't read from it, it just keeps accumulating. And eventually your server will crash. It doesn't have a circuit breaker, a safety mechanism that says only keep log entries for this many days or for this many gigabytes or this fraction of disk space, or it has none of that. It just happily keeps accumulating more log if you don't read from it. Why is that a problem? Well, say if you're using a pipeline like Fivetran to replicate your Postgres, we're kind of removed from the customer, right? We just provide this pipeline service. And if, let's say, something changes in the network configuration of your Postgres database, Fivetran can no longer access it, so it can't replicate. Now, of course, we send email reminders and all kinds of alerts, but if you don't pay attention, your database is going to crash just because you have the logical slot activated. So yeah, that's a big problem. I'm trying to find Postgres developers to talk to about this, convince them to fix it. Okay, and the opposite problem is when the log retention is too short. So that problem is when, if you're trying to import, so like let's say you have a huge database, thousands of tables, each one of them is many gigabytes, takes a long time to import. Earlier I described the process of Fivetran database replication as first we import everything, and then we start doing incremental updates. Well, guess what happens if your import takes 4 days and your log retention is only 24 hours? And this doesn't happen to Postgres, of course, unless you have little disk space, which you shouldn't. Don't have too little disk space. But like MySQL has a specific time limit for log retention. So say you have it set to 24 hours and it takes 4 days. So you finish your 4 days import and now you start to try to do your incremental updates. What's going to happen? Anybody? What's going to happen?
You lose data.
You lose data. How much data do you lose?
3 days.
3 days of changes, exactly. Not a good situation. So you need to periodically take a break from importing and catch up with a log. So that gives you another interesting problem, which is, well, how do you reconcile the import and the update? It's like you got two different data streams. You got rows for a given table coming from here, and rows for a given table coming from here. And how do you juggle them so that you don't overwrite the later row version with an older one, right? End up with data corruption. So the thing to realize there is that each row is independent of other rows. And for a given row, either import or update is always going to give you the latest row version at the end of the day. It's a little bit confusing to think about it, but it's one of my favorite problems to think about. And so this is how it works, right? So let's say you have a timeline where you have 3 modifications of that one row. And so after the first one there is the time when we last processed the log, right? So we're up to date up to the first of these row modifications, but not the second 2. So 2 things can come after this, right? The next thing we could do is do a little bit more import, or we could do log catch up. If you do import at the end there, of course you end up with the latest row version. You may miss the middle one if you're doing some kind of replication of change history. But you're not going to miss the final picture of the table. It's going to look accurate. Or if the next step is to do log catch-up, those row modifications create events in the log. And so if we do log catch-up, then of course we get those 2 modified row events. So it's possible, right, that we did an import. Unfortunately, it doesn't work here. So like let's say you did an import like right here, right? So at that point, you've got this row version, but the last log processing was here, right? And now you catch up with a log all the way from here to here. You are going to overwrite an older version of the row, but then you will follow it up with the latest version. So you still get eventual consistency. And what this enables you to do is you can do this thing where you import a piece of a table and then catch up with a log, and then import another piece of the table and then catch up with a log, and then third piece and so forth. You can divide up a billion row table into 1 million row increments, for example. And because of this, you always end up with a eventually consistent set of rows at the end of the day. And so, given all of everything that we talked about, then there's a common algorithm that works for all of these database types, whether it's NoSQL or whether it's a SQL database. And this is how Fivetran works for most of the databases. You just you create your import list, but you don't just iterate the import list and import. Instead, you go back and forth between import and update, as we just explained. And in that, in this oscillating phases, back and forth, in each import phase, you just kind of pick the table from the list that's not yet finished. You import one page from that table, and then you use a cursor to keep track of where you are. It does mean you need some way of tracking. For example, if you have the table in primary key order, you can use the primary key as a cursor, so you know where to continue next time. Right, so then you take a break from import, you go catch up with a log, and in the log processing, you just you have another cursor. You process from the previous log cursor to the most recent entry in the log, and then you save the cursor there, and you go back to an import phase, and you just oscillate. This is a general algorithm, not only like this import, you think maybe this is only relevant at the beginning when you first connect to the database, but no, because I mean, you can add a bunch of tables at any time, right? Add one table, add 10 tables. Maybe you had 10 tables, you add 100. So then adding 100 looks much more like the initial import. There's really a continuum between import and update. And so this algorithm applies at all times. Anytime there's something to import, you're going to do this oscillating thing back and forth. And so because all of these databases, they have enough information about the inserts and updates and the deletes to do it all from the log, right? And then when any of the schema changes happen, which unfortunately are terribly inconsistent in how to get them, but the one thing that always works is anytime when you notice some change in the log, like number of columns change or like the type of column changes in the log, you just say, okay, we don't know about this table anymore. We're going to start over. You throw out the list of columns that you thought you knew about it, and you go to the information schema, read it again, and you treat it as a new table. You re-import it. And that's how we universally deal with that situation. The reason is because it doesn't happen very often. New tables don't happen that often. We are, of course, thinking about optimizing so we don't have to re-import all of this, but then you do different things in different situations and that gets tricky. So anyway, so that's it for the actual talk about stuff. And I was going to just show you guys a quick demo. If I can get my cursor back. The cursor's gone. Oh, there it is. All right, got the cursor in good shape. Right, so here, for example, is what a Fivetran dashboard looks like. So I have a testing account configured here with lots of connectors. You see over here it says connectors 161. If you don't see it, it's quite small. It means that we have connected 161 different data sources, just because everybody at Python uses this for testing stuff, so we just use it as a dumping ground. I created one called Aurora test right here. So this Aurora test, Amazon Aurora, probably know is very into MySQL. And so I connected it, and over here I have a terminal open where I created a table. And oddly enough, I didn't realize that this was going to look too small for you guys. I wonder if I can change the font. Do you really change fonts in this?
Good of you.
Does that doesn't break here, does it? That's like browser thing. Oh, it works.
There you go.
Oh, wow. You're my savior. Thank you. Special award for you. All right. Is that big enough for people to see? Yeah. So I created this thing here. This table. Create table test ID int primary key data text. And I inserted values 1 and foo in here to convince that we have them. We're going to select from this table, select star from test. And it has ID and data, 1 foo. Perfect. And then when you have this connection set up in Fivetran, it just replicates it, in this case, to BigQuery Warehouse. Why BigQuery? Because that's what I have set up here. When I click on the Warehouse tab, it says BigQuery, and I have that BigQuery open over here. And there's our table. It has column ID, has a value 1. I'm going to make this bigger too. All right, is that big enough? You can see ID is 1 and data is foo in this last column. It has also these 2 other columns which Fivetran tacks on by default. One of them tells you when we synced the row, and the other one tells you whether it's been deleted. Why? Because we use this philosophy of additive replication, which means that we don't remove any of the data. So if you have any old row versions, we keep them around in your warehouse in case you find them useful. You can always delete them yourself if you like. But in some analysis, like if you're doing some type of historical analysis, you might find it useful to reference old row versions. And so it's just a flag. And so just to show you how easy it is to set one of these up, let's say I want to add a new database. All I would do is go to that upper right-hand corner. I'm trying to magnify this. It's not doing it. Oh, there we go. So click the connector button. You get a list of connectors here. And this was the choice that I made, Aurora MySQL. There are also many other kinds of choices here. Databases. You can get a list of just the databases there. There are web applications you can connect. There are event tracking things you can connect. And it's super quick and simple to set one up. Let's say you wanted to set up Postgres RDS. You just fill out a host port, user password database, whether you connect them directly or through SSH tunnel, save and test, and off it goes. And it replicates just the way I showed, where it just shows up in BigQuery shortly thereafter. And you get to choose different replication frequencies. So right here, there's a slider. It's set to 5 minutes right there. So this is updating once every 5 minutes. And if you're getting patient, you can click this little arrow that says sync now in the upper right corner, and we'll do it right away. why do we have this replication frequency for processing logs? Shouldn't we just be putting every row as it comes directly into the warehouse? You can tell me why we don't do that. No, because actually it has to do with the destination. So data warehouses are very inefficient for inserting individual rows. They're very efficient for inserting lots of rows at once. And so we just collect a bunch of rows before we put them in there so that we don't overwhelm the warehouse with lots of inefficient queries. And that's it. And I encourage you guys to try this out for yourself. It's easy to sign up for Fivetran. You know, all you have to do is, like if I were to log out right here, you can just sign up. You can either use your Gmail account for ID, or you can use email and password. And no matter which way you do it, if you click next, it just takes you to first set up your warehouse, and you can either, if you have your own, put in the credentials for that, or you can choose Manage BigQuery, which is what was in the demo account, where you have to do nothing at all. You just press go, and we create the warehouse for you, and you can connect the data sources. Within a few minutes, you can be up and playing with these if you want to try. That's it from me. Any questions?
Wait, before we take questions, I want to remind everybody we are going to be giving away a $200 Amazon gift card. You have to do exactly what he just did to win. You put your business card in here. If you do not have a business card, by all means, make one on a piece of paper with your full information. Just the name alone, you will not win. But I guess we could pass it around if anyone wants. Otherwise, we'll be here, and we're gonna give this away right after the QA. So hang tight, and let's take the next question. First question. Who's got it? It's in the back.
Sometimes the source, sometimes the sync may not support joins. I didn't think that BigQuery would support joins. So how does that work if you are replicating from a highly, normalized data source?
Yeah, so BigQuery, it does actually support joins. It just doesn't support foreign keys. Yeah, so it's missing the constraints, but it can do the joins nonetheless. Yeah. Yes.
What's the pricing on this? Mostly enterprise, or maybe have startup?
Well, as it happens, we have our beautiful sales representative Courtney over here. I would refer all such questions to Courtney.
I was just wondering on like because you mentioned the demo that we can sign up. I'm wondering what some of the is it mostly enterprise? Because some of the integrated data sources are applicable to startups.
Yeah. I think we geared towards kind of all over the spectrum. We do have very large enterprise customers, but we also play well in kind of like the 50 above space. And then additionally, we do have more startup customers. So we price on like a per tier connection, so it's not based on volume. So you guys have a little bit more predictable pricing year over year. And depending on what connectors you guys need, we'll make a package for you and figure it out that way.
Next question.
Yes.
So I was wondering, like, is it like, say you source is in one data center and your destination is another data center, you're configuring your site. Is it downloading some agent onto the source and destination machines, or is it just pulling and pushing to the other side from your machine?
Right. So if you're going from one data center to another, we just go over the network. So the data. So Fivetran servers connect to the data source, and Fivetran servers connect to the data destination, and then just pipe the data through. It can be inefficient in some cases if you go from one data center to another over the large internet, but
Or even in same data center, if I want some like on-premise.
Yeah, that's right. So from the same data center to the same data center, these work can be inefficient because you'd be going out to the Fivetran servers and then back again. So that's, those are things we're working on for the future to make those things more efficient.
Yes.
How do you handle security with all this data moving around? You just have to encrypt all these connections?
Absolutely, yeah, that's
Or
right.
Is
Yeah.
that within the Fivetran system? You have to handle your own way.
No, Fivetran keeps everything encrypted as long as your data sources and destinations support it. So we do allow unencrypted connections if that's what you want, but we make that more difficult to configure. By default, it will be encrypted.
And also like how much data is, what kind of data is retained on your server, and like, is it like you could choose from where that can reside?
I'm sorry, what was the last part?
So suppose I have my data in one data center,
Yeah.
so I'm replicating via
Yeah,
so the location of these Fivetran data servers,
yeah.
wherever it is it possible for the customer to choose, okay, I want servers in this location versus?
Yeah, right. So currently, the Fivetran servers are all in Amazon's US East. But in the future, they will be located in various places, and you will be able to choose for sure. So there.
And other thing was like how much like do you retain some data, or like once you push to start?
The data only stays in Fivetran for as long as it's being processed and transmitted to the warehouse. And it's immediately dropped thereafter. We have a 24-hour retention policy, no more than 24 hours.
Next question? Time for one more. Yes.
Yes.
Yes, you mentioned about the cascading deletes, right?
Oh, yes.
Yeah, that's not tracked in the logs.
No.
So your last slide is the solution, general solution for all data. I didn't quite catch the last slide.
Yeah, that one, that doesn't even help that doesn't help with the cascaded deletes.
Okay.
Cascaded deletes are a real problem.
What
We're
about-
still figuring out how to solve that one.
Okay.
We recently found that out. What's that?
Maybe you keep on monitoring the relations and build your own.
Yeah, I mean, that's basically what you have to do is you have to query the relationships, right? So the information schema will tell you that there exists a cascading relationship.
Yeah. So track that.
And then what you have to do is you just observe an event on the parent table, and then you know, okay, this will trigger a child table event, and then you apply that in the child table. But that's technically pretty complicated. It's like we try to do that and we couldn't do it right away. It requires a new type of operation that we would do in the destination warehouse.
Right.
So tricky stuff.
But what triggers would they work? Like if one table got updated and a trigger caused another table to get updated, those would be locked, right? On the
Triggers,
logs.
yeah, triggers. Trigger changes do generate their own events in the log.
Okay.
Yeah.
Thank you.
Do you have your hand up?
Yeah, I just
Now we can take one quick
just to file that their QA checks are done to ensure that the result of the table is the same as the first table, or is that?
Yes, we. Yeah, whether we do QA checks, that destination and source tables are the same. So we do very extensive testing of the pipelines themselves. We have unit tests and integration tests that we run all the time with all kinds of edge cases and everything. We don't currently support like checking your particular table and source and destination. We've kind of gone back and forth on that because it's sort of circular logic to say that you're going to check that, because like if there's a flaw in your replication of data, you probably have the same flaw in checking that the data is valid. Maybe that's not the case. So, but we never really decided to do that. Maybe we'll get it in the future. A very good question.
That is all the time we have for Q&A right now. However, Mel is here for one-on-one questions right after our raffle, so you will be able to have a chance for everyone to get their questions in. I want to give a great big round of applause. Thank you to Mel. Who wants to win a $200 Amazon gift card?
I do.
All right, can I ask you to mix it all up?
Yeah.
Don't put yours on top. Okay? Can I ask you to look that way and reach in and pull one out?
Oh, God.
All right, read it out loud. Read it out. You're looking at the blank slate, the other side. Oh, it's both sides.
Brian C.
Brian C.
Brian C. on
Who's
the
C?
paper
Wait.
plate.
What's C?
Yeah.
Brian
And
C.
C, last name, man. Is it Sean?
Yeah.
Okay, that's you? All right, congratulations, you won. We will email you